So in this video, we're going to see problems from exercise 8.2, which belongs to chapter number 8 quadrilaterals. And this is problem number 7. So let's read what the problem is. ABC is a triangle, right angle at C. So as you can notice that there is no figure that is given to us. So we have to construct our own figure. So let us draw a triangle ABC, which is right angle at C. So this is a right angle triangle. Yes. So C is this point where this is having right angle triangle, and then this is our hypotenuse AB. Okay. So this becomes our triangle ABC, which is right angle at C. Now let's read further. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Okay, so a lot of things are mentioned here. Let's break it down step by step. First of all, we need a line through the midpoint M of hypotenuse AB. So let's highlight this midpoint M of hypotenuse AB. So let's get the midpoint M. Let's say this is my midpoint M, okay, of hypotenuse AB. Now we need a line which goes through M and parallel to BC. Okay, so this is our side BC. We have to draw parallel to BC line passing through the midpoint M. So let's construct that line as well. So this line will be something like this. Okay, and it intersects AC at D. So this is AC, it intersects AC at the point D. So let's mention this point D. Okay, so yes, the construction is done. First of all, the triangle ABC was given to us, and this it was right angle at point C. Then we took the midpoint M of the hypotenuse AB, and we just constructed a line parallel to the third side BC, and this line will touch the line AC at point D. Okay. Now show that, and there are three things to show. Let's go step by step. Let's focus on the first thing. Show that D is the midpoint of AC. So point D is the midpoint of AC. This is very obvious because it's a straightforward application of converse of midpoint theorem. So I'm just going to write here. Yes. So by let's use different color. Okay. Using converse of midpoint theorem. Using converse of midpoint theorem. Okay. We can say that D is the midpoint. D is the midpoint of AC. D is the midpoint of the side AC. Okay. Why? Because this was a midpoint and we drew a line parallel to the third side. So whenever it goes to the other side, it will touch at the midpoint of the other side. That is what is the converse of midpoint theorem. So first thing is very straightforward. It's done. Now second thing. What does the second thing ask? That MD is perpendicular to AC. This line MD is perpendicular to line DC. Again, by construction, so let's come down and let's say point number two. So by construction, we have MD as parallel to BC. MD is parallel to BC. That is by construction. So here it is parallel to BC. It was given in the question itself. So MD is parallel to BC. Now, if these two lines are parallel to each other, and if AC is the transversal, okay. So consider. So again, I'm going to say consider AC as transversal. AC as transversal for these two parallel lines MD and BC. Okay. In that case, note that this angle will be equal to this angle because they are corresponding angles. Okay. Angle ADM will be equal to angle ACB because they are corresponding angles. So once again, let's come here. So if AC is a transversal, then angle ADM will be equal to angle ACB. Okay, why? What is the reason? Because they are corresponding angles of that transversal. Okay, and we know that corresponding angles are equal to each other. Okay, so but angle ACB is a right angle triangle, is a right angle, which means it's 90 degree. Therefore angle ADM is also equal to angle ACB, which will be equal to 90 degree. Okay, so we can very confidently say that okay, this ADM is also 90 degree, which means MD is perpendicular to AC. Okay, so in fact we can do like this. Yes, so that means MD is definitely perpendicular to AC. So point number 2 is also done. MD is perpendicular to AC. Now the third thing we want to prove is CM. So this is C and this is M. CM does not exist. We have to draw it. So first let's draw CM. So what we will do is I will create a copy of this. Okay, let's not create a copy. I will use this space. So okay, let's come here now. Now the third thing that we want to show is CM. So this line CM is equal to MA. So this is our MA. That is equal to half of AB. So we already know MA is half of AB because M is the midpoint of AB. So first of all, let's construct CM. So CM will be something like this from this point to this point. Okay. So point number 1. So I'm going to just write here point number 1. MA is already half of AB. Okay, because M is the midpoint that is given. M is the midpoint, okay, of AB. So that is given to us. Now we have to prove that CM is equal to MA. Okay, so if you consider these two triangles that we have here, I'm going to highlight it. Triangle CMD, this is one triangle, and triangle AMD, this is another triangle. So if we prove that these two triangles are congruent to each other, okay, then we can say that CM is equal to MA. Quite simple and straightforward. So once again, I want to erase this. That was just to highlight. So okay, let's consider triangle CMD, okay, and triangle AMD, okay. So two things are very obvious. One is angle CDM is equal to angle ADM. Okay, why? Because both are 90 degree, 90 degree. Just now we proved it that this is also 90 degree. So CDM, this angle is equal to ADM. Okay. Now second thing, or the second point is MD is equal to MD because they are common side. So MD is also equal to MD. Now the third thing we want to prove is yes, D is the midpoint of AC. Okay, we just proved in statement number 1 that D is the midpoint of AC, which means AD, let me use marking here, AD will be equal to DC. Okay, AD is equal to DC or CD is equal to AD. So just to highlight this thing, CD will be equal to AD. Okay, 1-to-1 correspondence. So let's try to zoom out a bit. Yeah. So point number 3 is going to be CD is equal to AD. Why? Because D is the midpoint. So let me just write it here. D is the midpoint. That is from first statement. D is the midpoint of AC. Okay. So now, if you consider this triangle, these two triangles, CMD and AMD, so we have this side, and angle. This angle CDM, okay, side, angle, side. So it's a SAS test of congruency. So let's come here. Or okay. So all I want to say is from this discussion, okay, from this discussion we can conclude that by SAS test of congruency, SAS test of congruency. Note important point that angle A has to be inclusive between the two sides. Okay, so side, then this angle and this side. That's how we got the SAS test. By that test of congruency, we can say that triangle CMD is congruent to triangle AMD. Okay, and once we say CMD is congruent to AMD, then all the three sides and all the three angles are also congruent to each other. But what we are interested in is the side CM. So I'm going to highlight it, which means this side CM is equal to side AM. Okay, that is, I'm just going to say that is CM is equal to AM. Okay, and that is what we have been asked to prove. CM is equal to MA. MA and AM are same, and MA is already half of AB. So thus point number 3 is also proved from this question. So thus, as we can see, for this question number 7, step by step we went and we proved point number 1, point number 2, and point number 3.